video, we're going to look at how to perform stoichiometry. So when you look at a balanced chemical reaction, you'll see coefficients, which are the numbers in front. If you don't see anything there, it's a coefficient of 1. And these coefficients tell me the ratio of molecules that are reacting in a chemical reaction. So it's telling me 2 molecules of H2 react with 1 molecule of O2 to form 2 molecules of H2O. I could also scale up by a factor of 6.022 times 10 to the 23, Avogadro's number, and I can say that these also represent mole ratios. 2 moles of H2 react with 1 mole of O2 to give 2 moles of H2O. So similar to when we were figuring out formulas, and I said those subscripts represent atom or mole ratios, same thing with these coefficients. They represent molecule or mole ratios. These ratios always have to stay true in your reaction. So if I start with 1 mole of CH4, I would need 2 moles of O2. It would give me 1 mole of CO2 and 2 moles of H2O. If I don't start with 1 mole of CH4, if I start with 2 moles instead, then I would still need double the O2. I would need 4 moles of O2. And then 2 moles of CO2 would be made and 4 moles of H2O. Everything would double. If I started instead with 3 moles of CH4, everything would triple, but notice that these ratios stay the same, 1 to 2 to 1 to 2, 1 to 2 to 1 to 2. We can actually say that 1 mole of CH4 and 2 moles of O2 are called stoichiometrically equivalent quantities, and we can use these to actually convert between different substances in a chemical reaction. We can make what we call conversion factors. So I could say 1 mole of CH4 would always react with 2 moles of O2. These are stoichiometrically equivalent quantities, so we can make a conversion factor out of them. And this would allow us to convert between moles of O2 and moles of CH4, or moles of CH4 and moles of CO2, or moles of CO2 and moles of O2. So I can convert between moles of any of these reacting species or products, as long as I have their coefficients that I've seen in my balanced reaction, meaning if you don't have a balanced reaction, make one. And then once you do, you can use these coefficients to convert between moles of different substances. Key word here being moles. And that's why I always say, when in doubt, mole it out. You have to be in moles to touch those coefficients. Okay, take a moment, look at this example. How many moles of water are formed from 1.47 moles of methane? Methane is CH4. So let's write this out with dimensional analysis, because that will make our problem solving technique a lot easier. So I'm going to start with 1.47 moles of CH4. I'm not only going to write moles, but I'm going to be very specific about my unit. Moles of what? Moles of CH4. So make sure when you're writing these out, you put grams, moles, whatever your unit is, but also followed by a formula, because we're not going to end up being in stuff about CH4. We're going to end up being in stuff about water. Okay, so I'm in 1.47 moles of CH4. If I have moles, I can go right into using these coefficients to convert from moles of CH4 into moles of water. So I want moles of CH4 on the bottom, so they cancel. I want moles of H2O on top, so I'm left, and I'm getting what goes into my conversion factor from the coefficients in front. CH4 has a coefficient of 1, that goes in the bottom. H2O has a coefficient of 2, that goes in the top. And I get 2.94 moles of H2O. Try to keep your significant figures the same as your starting measurement. How many moles of Li3N are formed from 9.2 moles of lithium? Okay, start with what you're given in your problem statement. 9.2, be specific. Moles of what? Li. Do I have moles to start with? Yes, so I can go right into using these coefficients. I want Li on the bottom, moles of Li on the bottom, so they cancel. I want moles of Li3N on top, and I'm getting what goes into these coefficients from my conversion, what goes into these conversion factors by my coefficients. 6 goes with the Li on the bottom, 2 with the Li3N on top, and I'm multiplying by 2, dividing by 6, I get 3.07 moles of lithium nitride. Take a moment, look at this example. How many moles of Li3N are produced when 16 grams of solid lithium react? So how do we approach this problem if mass is given instead of moles? Can I touch these coefficients yet if I'm in mass? No. When in doubt, mole it out. You have to be in moles to use those coefficients. So we will have to convert any mass amounts to moles before using the coefficients. Sometimes you'll have 3 steps. You might have to mole it out, then use the stoichiometry, the coefficients, and then turn back into mass. Okay? When in doubt, mole it out. Okay? So let's try this problem. I'm going to write 16 grams of lithium. All right? Can't touch the coefficients yet. I'm not in moles. When in doubt, mole it out. I want grams of lithium on the bottom to cancel. I want moles of Li on top, so that's what I'm left with. And the molar mass of lithium, 7 grams per mole. So the 7 goes with the grams. Remember, the molar mass always goes next to the G. All right, now I'm in moles of lithium. I'm in moles. I can use those coefficients to change from moles of lithium to moles of lithium nitride. Okay, I want 6 moles of Li on the bottom. That's the 6 that goes with Li. And the 2 I'm getting from the coefficient, Li3N. And now I've successfully changed into moles of Li3N. This is the part where you're using the coefficients that we call stoichiometry, or stoich for short. Take a moment and try this example, then check your work. So I'm starting with 1 gram of glucose. I can't touch those coefficients if I'm in grams. I have to be in moles. Those coefficients represent mole ratio. So when in doubt, mole it out. I can use the molar mass of glucose. The molar mass should go next to G, so that goes in the bottom, so grams cancel. And now I'm in moles of glucose. Now that I'm in moles, I can touch those coefficients. So I use 1, glucose has a coefficient of 1, okay? And so that's going to go with glucose. H2O has a coefficient of 6 that goes on top. This is the part that we call stoichiometry. Now I'm in moles of H2O, but check that that's what you want. I don't want moles of H2O, I want grams of water. So there's one more conversion factor I need to now convert from moles of water into grams of water. And that's using just the molar mass of water. So I want moles of H2O on the bottom, and I want grams of H2O on the top. For every 1 mole of H2O, there's 18 grams of H2O. And then I get my answer, keeping 3 sig figs. Now notice that I'm only touching the coefficients at one point in these conversion factors, in this one conversion factor that I have labeled as stoichiometry, when I'm going from moles of one thing to moles of another. Notice in these 2 conversion factors, where I'm changing from grams into moles or moles into grams, I am only telling the molar mass associated with 1 mole. So notice I have not touched the coefficients. Whether for H2O, whether this was 6, 8, 100, whatever this coefficient was, the conversion factor to change from moles into grams would be the same. 1 mole of H2O weighs 18 grams. This conversion factor is based only on the formula, not on the coefficient. Okay, so that's an important note. You're only using the coefficients when converting between moles of one substance and moles of another, conversion factor labeled stoich. Do not use the coefficients when calculating molar mass or converting between mass and moles of the same substance. Again, whatever coefficient was in front here, whether this is 1, 800, 52, it doesn't matter. 1 mole would weigh 180 grams, despite whatever the coefficient is. And same thing here for H2O. Doesn't matter what this coefficient is for this conversion factor. 1 mole H2O is 18 grams. I'm just getting it from the formula. Okay? Take a moment, try this example, and then check your work. 1.5 grams of sodium to start with. When in doubt, mole it out. We've got to change this into moles. So I'm going to use the molar mass. 23 grams of sodium is the mass of 1 mole. Now in moles of sodium, I can use the coefficients. 3 moles of sodium is equivalent to 1 mole of aluminum in this reaction. Stoichiometrically equivalent quantities. And now I'm in moles of aluminum, but they ask for mass of aluminum. So I can use the molar mass, there's 27 grams of aluminum in 1 mole, to change the moles back into mass. Notice that even though there's a 3 in front of sodium, when I was changing grams into moles, I didn't use that 3. All I'm doing is looking at the formula of Na, which is just Na, and writing the molar mass. Whether this was 3, 5, 10, it would be the same conversion factor here. Take a moment and try this example. Notice that in this example, there is no chemical reaction. So you have to write and balance a chemical reaction in order to create the coefficients needed as your conversion factors. So first, write your reaction. C5H12 reacts with O2 because this is burning implies combustion. I get CO2 and H2O, but it doesn't matter which one comes first, which one's second, as long as both of those are products. Okay, I'm going to balance carbons first. So I would need 5 CO2s and 6 H2Os to balance out the carbons and hydrogens. And now I'll notice there's 10 oxygens and 6 oxygens, so that all together 16 oxygens on the right. I need 16 oxygens on the left. So this, since something would be multiplied by 2, I would need half of 16, or 8 O2. And this would remain a 1. So these are my coefficients. Now I can go into my problem. So sometimes you might have to write a balanced reaction first. Okay, so I'm going to write 10.5 grams, be specific, C5H12 to start with. When in doubt, mole it out. Let's change that into moles. It doesn't matter what the coefficient is here. This step would be the same. 1 mole is whatever the molar mass is of C5H12, which is 72. Now I'm in moles of pentane. I can change into moles of CO2 using the coefficients. Okay, 1 mole of C5H12 goes on the bottom to cancel. 5 moles of CO2 go on top. I'm in moles of CO2, but they ask for mass. So let's mass this back out. Do not use the fact that there are 5 CO2s anymore. You already used that in the stoichiometry conversion factor. So now I'm just looking at the formula CO2, which has a molar mass of 44. 1 mole of CO2 weighs 44 grams. And in my calculator, I do this out and I get 32.1 grams. Now, a lot of the problems that you've just seen, I'm always using mass, give you mass and ask for mass, but you can have other quantities as well. Like take a moment and look at this problem. You might have volume of a gas at STP, and then remember you can use that 22.4 liters in 1 mole conversion factor. Has to be only for gases and only at STP, standard temperature and pressure, 1 atm and 0 degrees Celsius or 273 Kelvin. Or you can use the fact that 1 mole is equivalent to 6.022 times 10 to the 23rd molecules. So let's take a look at this problem. Okay, so I'm going to put what I have to start with, 53.2 liters of CO2. I don't want to touch these coefficients until I'm in moles. So when in doubt, let's mole it out. So I have 53.2 liters of CO2. It is a gas. I'm at STP. Pressure is 1 atm. Temperature 0 degrees, that's STP, it's standard temperature and pressure conditions. So I can use 22.4 is equivalent to 1 mole. Be specific about your units, I'm still in CO2. Now in moles of CO2, I can change it into moles of pentane, C5H12, using the coefficients. It's a 5-to-1 ratio here. 5 moles of CO2 goes in the bottom to cancel. Now I'm in moles of C5H12. I don't want to be in moles, I want to be in molecules. So I can use Avogadro's number. There's 6.022 times 10 to the 23 molecules in 1 mole. And I can get my answer.